And let's take a quick look at our learning goal over here. Hannah, will you read that nice and loud for us, please?
I can multiply and divide integers using the pass rule.
Okay, I can multiply and divide integers using the pass rule. Well, we have this one rule called the PEMDAS, or PEMDAS, however you say it, rule, and that is for what? What is the PEMDAS rule for? Anybody remember? What does the PEMDAS help us do? Parentheses, exponents, and multiply, divide, add, subtract. What's that for? You don't know, you've just been using it as all? Wait. It's kind of like we do something with statements with it, they maybe aren't necessarily algebraic because we might possibly instead want to think of them as being numerical. Oh, come on, really? Oh. Ahia? Thank you very much. Order of operations. We use that rule for order of operations. Yesterday we learned some addition rules. Anybody remember anything about the addition rules? Because we got a lot of rules to keep straight. Can anybody tell me one of our rules we talked about yesterday? Because I'm not letting you off the hook until you learn these. So, what was one of the rules from yesterday? Oh my goodness, what an exciting crowd. You almost are going to put, the 88-year-old here to sleep. What's one of the addition rules? Okay, not the order of operations, but the addition rules. And you were here yesterday, so you might have to, guess, right? Oh my goodness, seriously? What happens when we add two positive numbers? Our answer is positive. What happens when we add two negative numbers? Our answer is negative. What happens when we add a positive number and a negative number? It depends. It depends. What's it depend on? Okay. The one further away from 0, what about it? Okay, so if the number further away from 0 is positive, then the answer will be positive. If the number further away from 0 is negative, then the answer will be negative. Okay, so now, if you didn't get those already memorized, I hate to inform you that I might have to, confuse you then, when I shouldn't have to. We're going to add some new rules in today. They are the multiplying and dividing rules. And we have to keep them separate. We can't say one's going to be the same as the other. It just doesn't work that way. It only works for multiplying and dividing together. They don't, thank goodness, they don't each have their own set of rules. It says, rules for multiplying and dividing are the same for both. Thank you. I only have to remember the rules. It doesn't matter if I'm dividing or multiplying. When both signs are the same, so we're multiplying or dividing with two numbers, and both signs are the same. Give me, what do I mean by the signs are the same? Either they're both negative or they're both positive. Okay, so when the signs are the same, does anybody know what the answer should turn out to be? Danny? The opposite? So in other words, if I'm taking a positive 3 times a positive 2, what do we get? 6. We get a positive, don't we? Okay, how about if I make that 3 negative and I make that 2 negative, or in other words, I multiply with their opposites instead. So negative 3 times negative 2. Anybody know what that is? Yeah? That's a negative 6, she says. Well, I'm going to have to change your mind, Hannah. I'm sorry. But when we are multiplying and they both have the same sign, a positive times a positive, let's put that over here in the margin. A positive, so just put a plus sign, times our multiplication dot, a positive, this is what, or a negative times another negative. Every single time we do that, here's what we should get. Give an equal sign to each of those crazy statements we're making. So the answer will always be positive. The answer will always be positive when you're multiplying or dividing with two numbers of the same sign. Now, how's that different from addition? How's that different from addition, Danny?
Addition, if you add two negatives together, you get a negative.
Yeah, in addition, if you add two negatives, you get a negative, don't you? In addition, it has a different rule. A negative plus a negative is a negative. You can't borrow money from somebody, borrow some more money from them, and all of a sudden be to the good. You know, like they're starting to say, you know what? Just keep, I'm just keep giving you money, and you'll never owe me anything. Negative plus a negative is a negative, but we just said for multiplying and dividing, a negative times a negative is going to be a positive. So we have to keep that straight now, okay? Well, this is called the pass rule. P stands for, what do you think? Positive. What might the A stand for? Answer. You will get a positive answer when you have SS. Same sign. Oops, I don't need the S there. It's already there. So you're multiplying or you're dividing. You have two numbers with the same sign. You will get a positive answer. That's the pass rule. Well, but it isn't always that way, is it? That both of them have the same sign. So we've got to kind of add on a little. We have to have a little addendum here. We have to say, well, wait a minute. What if when one of them is positive and the other is negative? Anybody know what the result should be then? Danny? Yeah. That's when you'll always get a negative. If you're multiplying or dividing, one of them is positive, the other is negative. Let's go over here and do that. A positive times a negative equals, what did we just say? A negative. Well, what if your first one is negative and the second one is positive? Would it be positive now or negative? No, it's still going to be negative because the rule says, the addendum to our pass rule says if they don't have the same sign, if one of them is positive and the other one is negative, it doesn't matter which one, the answer will always be negative. So how's that different than the addition rule? Carly?
Because when you add positive and negative, depends on which one.
Is there any, it depends in this one? No, there's no it depends in multiplication or division. It will always be a what? Negative. Okay, let's go to page 224 in your workbooks. Page 224. Let's go do some practice then. Activity 1. So your brain needs to kind of do a two-step process here, okay? Your brain kind of needs to do a two-step process. It's got to look at the signs and it's got to think of the multiplication facts, okay? And or the dividing. So in number 1, we have a negative 9 times a negative 5. The first thing I want you to always do is decide, should my answer be positive or should my answer be negative? What do you think, Derek?
Positive.
Why do you want it to be positive, Derek?
It's two negatives.
It's two negatives, yeah, they're the same sign, aren't they? So Derek's right, it's going to be a positive, so we don't need to stick a negative sign there, do we? Now we can just say to ourselves, what's 9 times 5? 45. Number 2. Now that we just did number 1, number 2 we should be able to handle, right? Number 2, a positive divided by a negative. First thought is, should our answer be positive or should our answer be negative? What do you think, Harley? Negative, why?
Because positive plus, positive divided by a negative becomes a
becomes a negative. When one of them is positive and the other one's negative, you have a negative answer, don't you? And 45 divided by 9, class, is? It's 5. So we have a negative 5 for our quotient. Wait.
Wouldn't number 1 be
Okay.
negative? It's a negative times a negative.
Okay, and what did we say in the past rule? Positive answer, same sign. So the 9 and the 5 are both the same sign. They're both negative, so our answer should be positive. Positive times positive is a positive. A negative times a negative is also a positive. Okay, now in this next one, number 3, let's look at the answer first of all. The answer says 56. Positive or negative? Positive. How do we get positives when we're multiplying? Because we're multiplying. How do we get positives? What are a positive times a positive and a negative times a negative. Well, since we have a negative 7, does that mean our other factor has to be negative? Yes, it does. So put the negative sign there first. And then say to yourself, what times 7 is 56? 8. So it's going to be negative 8. Because a negative times a negative is a positive. Okay, how about in number 4? The quotient is negative. And we start with a negative. We're supposed to divide by something. Should our something be positive or should it be a negative? It has to be a positive because when we've already got a negative, and if the answer is negative, that means only one of them can be negative. So we have a positive. And what do we have to divide 45 by? Now I'm just ignoring the signs. What do we have to divide 45 by to get 9? 5. So a positive 5. Okay, you try the next 4 on your own. See how it goes. Actually, once you're doing it, have the same thoughts that we were. It's a 2-step process. And I'll take 4 different volunteers. Got to go quickly and put an answer up there. Go, just go. I don't want to call on you. Just go. Don't run each other over, though. Be nice. Take turns. Two more. Okay. Okay, thank you. Anybody want to, after you're done, you want to look up and see, do anybody want to challenge any of these? Any of these answers need challenging? I'll move out of the way. Anyone need the process explained to them for any of them? So give me a thumbs up if you think you got this. Most of you, okay, that's good. Anybody want to ask any questions before we move on? Because guess what they're going to do to us in the next section? Adding and subtracting and multiplying and dividing. We're going to have to keep all the rules straight. Can we do it? Absolutely we can. Okay, the first one says negative 3 plus 7. Wonder what that is. What do we have to do? What does your head need to do here? Harley? Okay, find out if there's any 0 pairs. Would there be any 0 pairs in this one? How many? 3 of them, yeah. Okay, so then if there's 3 0 pairs, what's the answer? Ikea? 4. Ikea says 4. Anybody want to agree? Go ahead, give her some, affirmation here. Do you agree with her? Yeah. Okay. Anybody want to discuss it? Okay. Number 2, what's the first thing we're going to do, class?
Add the opposite.
Add the opposite. So how does this look when we add the opposite? 17 plus, and the opposite of negative 2 is? Positive 2. Okay, well now I bet you can do the answer, right? What is it? 19. A positive plus a positive is a positive, and you just add up their distances there. Or a number of tiles. Okay, number 3. Negative 6 times negative 6. Shout it out. Who's got it?
36.
36. Are you positive it should be a positive?
Yes.
Okay, I agree. How about 28 divided by -4?
-7.
-7, because a positive divided by a negative is a negative, and 28 divided by 4 is 7. Okay, go ahead, fill in the rest of them, but don't you dare leave subtraction as subtraction, because we don't have any subtraction rules. And I will again take 4 volunteers. If you didn't get to go up the first time and you're just dying to go up, we're gonna ask those other people to stay seated for a little bit, so you get a chance. These are kind of hard, huh? Three more opportunities. Isn't it a good thing God gave us fingers? See a lot of good thing we got them. Come on, I want some help. Help, help, help. Okay, I will let people who were up here before come back up, because these other guys, you can't count on them, I guess, sorry.
This is what we looked at yesterday, you have to change that. I'm telling you, that has to make it cut. To change that to that. And this one,
I did.
this one, change it to plus.
Got one left. Who wants it? Is that equal?
Negative.
So you want your answer to be a negative, is that what you're doing? Okay, and I just change this because it's a little bit confusing here. Okay, so you want it to be this. Is that right, Danny? Okay. Okay. Anybody else? Come on. Oh, that last one's too hard for us? Sure, Becky, you can do it. Okay, see if you want to challenge any of them, or you want to ask how they got the answer they did. If you didn't get it, this is your learning, not mine. You gotta make sure you are getting it. You may want to challenge any of them. Ask why. Okay, I can agree with all of them, so. Anybody need to ask why? Okay, then, let's just close up your workbook for a little bit again, okay? Let's go back to the notes handout that you had. And now we're on the bottom of the front side here. We've done our practice for now. Now we're gonna practice PEMDAS. Oh my, look at that. Oh. What do you suppose? And not within that statement. I want no one touching my numerical statement there. I do not want you changing it at all. I want us on the next line to do something that is going to help us be able to use all of our rules. Sierra?
Add the opposite.
Add the opposite. So there is, right here, the only thing I will let you do is circle. We have a subtraction there. This is a negative sign. This is a negative sign. We have a subtraction here. We have to be able to tell the difference between subtraction and negatives, right? So now in the next step, we are going to rewrite this, not up here. We're gonna rewrite this, changing the subtraction to add. And then what's the opposite of negative 40?
Positive.
Positive 40. We'll bring down our divided by, we'll bring down our -10, we'll bring down our plus, parentheses, 1 plus -4. That's all we're doing in that step. Now we're gonna follow order of operations. What comes first? Parentheses. So let's put a box around our parentheses, because that's the only thing we're gonna do in that step. What's gonna happen with everything else?
Bring it all down.
Bring it all down. It's coming along. One plus -4. -3. Good job. What comes next?
Division.
The division will come next, so now we'll box that. And everything else just comes along. 40 divided by -10. A positive divided by a negative, class, is a negative, and 40 divided by 10 is 4. So we have a -4 for that box. And bring down our plus -3. Next, addition. Well, we got 2 additions. Okay, we just work from left to right now, don't we? Okay, so let's box the 5 plus -4. What is that? 1. And last but not least, we are finally to the last thing. 1 plus -3.
-2.
-2. Circle, here's our final answer. Oh, see why knowing all those rules is kind of important? You suppose there's some other possible answers that we might have come up with if we hadn't followed some rules? Very possibly. Anybody want to ask any questions about it? Okay, we're going to go to the backside now. Now, you need to be paying really close attention to me and listening here, because, you know, it's almost gonna, you're gonna kind of feel like, well, wait a minute, you told us that we're always supposed to change subtraction to add the opposite. Well, here's the deal. That subtraction, the only subtraction that's in there, it's right here, isn't it? Is that the only subtraction in the problem?
Yes.
Yeah. Well, here's the problem. That subtraction, if we change it to add the opposite, we gotta know then what to do with that 3 squared. Because it isn't just a 3, is it? It's 3 times 3. So you know what we're gonna do? We're actually gonna cheat a little bit here. Because of this is not just a number, it's an exponent. And we are going to box this. And we're going to do that. Oh no, that would confuse you guys because we're supposed to do parentheses first. You know what? We're not going to box that. Unbox that if you did, just like I just did. I heard a what and I was like, yeah, you're right. What? Okay. So we're not going to change that. We're just going to start. So box the parentheses because that's where we start, don't we? So we have -7 times -3 plus -1 is -4. And then we're going to bring down our -3 squared. Why is it we're not changing that subtraction again? Tell me, what's the reason? Because it's an exponent, right? That's going to be our reason. That's the only time that I don't want you to do that, maybe because it just will make matters worse. Okay, now what do we do next? Box the 3 squared, because exponents are next in PEMDAS. So we have -7 times -4, subtract 9. Now that we no longer have that exponent there, we've taken care of it. We're going to circle this, and in the next step, we're going to change it to add the opposite. So instead of subtracting 9, we're going to add -9. The opposite of 9 is -9. So I did want to eventually get the subtraction out of there, but we are gonna wait until we've been able to take care of the exponent. Now what's next?
Do the negative 7 times negative 4.
Yeah, we gotta do the multiplication at the beginning here. Multiplication comes before addition. What's a negative times a negative, class? Positive. And 7 times 4 is? 28. $28 plus negative 9. Well, that's the last thing I want to do, isn't it? Oh, what's a positive plus a negative?
Positive is
Wait a minute. It depends, right? Okay, what's it depend on?
Which one's further away from 0?
Okay, well, which one is further away from 0? 28 is, and 28 is positive, so our answer is going to be positive. Okay, well then how do we figure out how much positive distance value we have? What do we do? How do we get that?
28 subtract 9.
Yeah, you really just take, you know what, we're taking out 9 zero pairs. We're overlapping, we're going positive 28 and then we're coming back 9 and so we're overlapping 9. We're taking 9, a chunk of 9 out of there, so 28 take away 9. Okay, well, what is that? 19. So our final answer is, and we already said it's positive, didn't we? Okay, lots of rules to keep straight. Don't be just like, oh, well, yeah, I think it's this, yeah, I think it's that. No, make your brain process through all of these rules. Okay, we're going to practice evaluating now. If they give us an algebraic expression, and then they say, oh, we want you to let the variable be this, we're going to substitute. So right here it says W is going to equal negative 12. So underneath the W, we'll replace W with negative 12. Negative divided by a negative, class, is a positive. How many 4s are there in 12? 3. Here's our answer. That expression is equal to 3 when W is negative 12. Okay, look at number 4. Look at number 4. A minus a negative 10 when A is a negative 10. Oh my goodness, do you think they could have a few more negative signs and subtraction? And what should we do first before we even substitute?
Add the opposite.
Add the opposite. A, instead of subtracting negative 10, we're going to add its opposite, which is positive 10. No substituting in this step, just renaming. And now we will put negative 10 in for A because that's what they want it to be. What's this? 0. These are opposites, aren't they? And opposites always meet at 0. They always meet at 0. 10 shaded algebra tiles or 10 unshaded algebra tiles, they would 0 each other out, wouldn't they? Okay, you try the last one. Okay, tell me what I should write on the first line underneath my expression. Anybody want to share with me what I should write? What would my work look like? Hand up, help me out. Caden, thank you.
Negative 5 times x.
It already says that. You want me to write it again?
Negative 5 times 4.
Okay, can I do the substitution step in this one? Thanks. We didn't have to change its name at all, right? Okay. Somebody tell me what that answer would be, Tyler? Negative 20, Tyler says. How do you guys feel about that? Thumbs up for Tyler? Okay, I give him a thumbs up also. A negative times a positive is a negative. Is there any it depends in multiplication or division? No, there is no it depends in multiplication or division, only in addition, okay. Well, I am gonna let us be done, so why don't you get out a sheet of loose leaf paper for me,